Hello there, this is Hans Forschner with Napcon Engineering. In this video I discuss the input and graphic features that are part of the cartography and the 3D graphic modules. My prime goal is to show how to create complex buildings with different heights, roofs, substructures, balconies, floating structures, and how to present these buildings and roofs in the Geo-Database or in the graphics. The 3D view with hidden line and hidden surface algorithms or outputs is available in the Geo-Database. This is to check the input model, and in the SoundPLAN Graphics for presentation of input models or input models with result data. Let's get started. I open up the Geo-Database. I open up a blank situation that I already created. I'll go right here to the left top corner, and I'll get started with just putting in a very simple building, rectangular building. So I'll get started by just dragging with the left mouse an open window, a rectangle, and then here we can define, okay, this is a building that is 20 by 25, actually make it 30 meters long. I click on the check mark, and let me go through the input here in a lot of detail. So here we have our input building. So here you can put, of course, the address. Here we can define which layer, any additional information about road, building numbers, the building height. I'll set up with 8 meters. Then here we have receiver heights. This is kind of important, especially for high-rise buildings. If you want to show, for example, the different floors. We'll see that later in the video. But then, of course, in terms of the facade calculation, we can basically define the different floor heights from the first floor to the top floor, and then the program can automatically run the model around the building and calculate or consider all the floors. Here in this case I would put in a 2-story building, and down here we see, of course, the geometry based on this rectangle that I put in here. One thing here you may notice, here is a building floats above ground. We will use that later for building structures that are floating. That could be a balcony, it could be a building on stilts, or just a floating structure that is maybe floating over another building. So we'll see that maybe also later in the video. Then here's the facade noise. So here we can turn on which surfaces or like building surfaces are calculated in a facade calculation. We can select all, invert selection. So these are basically on the individual base. You can turn on and turn off these options. All right, so let's get started here with this. I'll move it a little bit here in the center. And when we look at this in the front view, of course, we only see the square, the side view, the projection to the from left to right, and then here we have the wireframe. So here we can see the whole thing like a 3D wireframe of that building. Now, there is, if you have the 3D graphic modules, we can also see a 3D map view, and this will be the 3D map view. So in this case, we see a solid line or solid surface model of that building here. And in this case, the sides are yellow and the top is gray. So this is depending on the type of building type that we assign to that. So I'll talk about that a little bit more later. All right, so let's go reset this whole thing again, and we'll go back to the top view. All right, so let me copy this building and make a copy of it. And in this case now I want to add a roof line in here. So roof line or ridge is defined by using a noise protection wall here. Now this noise protection wall will have no wall height, but it will be defined as the object type ridge. So let me kind of do that as an example here. So here I'll define the ridge line starting right here, going all the way over both edges of both facades. And in this case, yeah, this is fine. And we define this this noise barrier with 0 height right here. And the height of this, the building was 8 meters, so I'll put it at, let's say, 12.5 meters. So I'll define the relative height 12.5 meters above the ground. So this will be 4.5 meters above the edges of this building. So let me take a look at that. And again, in this case, front view is not really, just shows us a point. Side view, it shows us a line at the top. And then here we have a wireframe like this here. All right. Okay. Now, what is still missing here is we haven't really declared that as a ridge line. So in the 3D map, we also don't see really anything in detail. So let me select this ridge again, or this barrier at the top, and I create edit, and I change the graphic type to a ridge. All right. So now that it's defined as a ridge, we can go back into the 3D map, and now we see the difference of the display. So here we now see that we have a saddle roof here going up and down on both sides. And so let's get started and make some additional changes. So if we copy again this building with that ridge, and I'll copy it over here, and what I'll do is I'll take that ridge line and make it a little bit shorter, like this here. So what that really basically changes, it basically changes it into hipped roof structure. I think that's how it's called. So let me take a look at that 3D map. So now the program will kind of change the roof structure, and the ridge is right here, and then here we have the additional lines right here. All right. Okay. Now if we have a more complex layout of the building, so let's make it a L-shaped building. So this is building 2, and I'll set it up with a rectangular mode. So here we have now an L-shaped building. And in this case, I'll take this ridge line and I'll put it in here. And I add another point in here. And so now again, of course, my rectangular mode is bothering me here. Okay, so let's just see here. Let me zoom in. So here we have 1 point, second point, and the third point right here. So now we can see that this will effectively hitch the building. 3D map. So now we have this type of roof line here. Now in terms of the noise model, the program will only consider the actual building structure and the actual ridge line here in terms of the barrier effect of that building ridge. It does not consider any of these additional lines that we saw in the 3D graphics, from the ridge lines to the corners. So that's maybe just something to be aware of, that this is of course mostly for the 3D display, but that we can control some of the display features here. But in terms of the actual calculation, the program only uses the actual building structure, in this case the walls of the building, and the ridge line as basically where the sound has to diffract over. So here we are back to the different inputs that we just played around with. So here we have the flat roof, then here we have the gabled roof, the shedded roof. Here we have a building with the L shape. And then of course we can continue some of the roof shapes by adding additional lines to this. So here, let me just add as an example here, I'll add 2 additional lines here. And these lines will be slightly different in height. So this one I'll make 11. And then I'll copy that 11 over here. And now this will look like it's more like a mansard or a gambrel roof. So here you can have a lot of changes here. So let me stop at this point and just add additional roof buildings into the situation, and so you can kind of see the variety of buildings that we can have here. And so here we have a variety of buildings. Down here this is just a rectangular building. Here we have 2 buildings on top of it. So this is a building that starts at 30 meters in height. That's the roof level of the background building, and then it's another 5 meters from there. So that could be, for example, a tower for elevators, for example. So let me turn on the 3D view so you can kind of get an idea. So here this is the building with the 2 elevator buildings. Then here the next building is a side building. So here we have a structure that is sticking out. This is a floating building. So this is a building that floats above the ground, which means that the program in terms of the propagation will calculate over the building, around the building, and also under the building. So we have 4 paths in terms of shielding effect. Now, because the building is overlapping with another building here, the program will know that these buildings are connected. So in terms of the shielding effect, that may be something that it's considering, depending on where the source and the receiver is. Now the next building structure is a little bit more complex. So here we have 2 buildings at the bottom, maybe 20 stories high. We have some intermediate buildings on top of it, and then we have one big building that is basically floating on top of all of it. So there are some hotels, I think in Singapore, that are spread over 3 towers with a big floating building on top of it. All right. Again, by overlapping and floating those buildings, of course, the sound can go underneath this big building at the very top. So it can go through this area if the line of sight is not broken. If the line of sight is broken, then of course the sound goes either over, under, or around the buildings. Then after that, the next structures are like 3 towers with different heights. Again, we have 3 buildings that are overlapping with different heights. So here we have something with 60 meters in height. Then we have here a 40-meter tower and then another 60-meter tower. All right. Next structure is basically 3 circular buildings on top of each other. And so they start at 20, 40, and 60 meters, or go up to 20, 40, and 60 meters. And they are stacked, and of course you can do that stacking to whatever height. Then this next structure is a little bit more complicated. Maybe again two buildings in the at the bottom. Then we have a walkway between those buildings here. right here. So that is some sort of a walkway at the elevated point. So again, this is a building that is floating right here. Then we have some additional substructures here under this ring, and then of course this ring by itself. So this is again mostly created out of circles and then connected, and so basically this is one big building that is overlapping right here. And again, the surfaces are used for the reflection, shielding if you have the line of sight broken. Other than that, the program will use the floating structure of that so that the sound is going over and underneath that building. All right, so here a couple more examples of other structures. Here is a triangular building. So a building can be any type of shape. So this could be a hotel with some kind of like conference room at the bottom. Then here we have like a staircase, a stairway, basically a building with different elevations. So this is defined by adding multiple buildings side by side with different heights. They are all overlapping slightly, and the overlapping again ensures that these buildings are connected, and the program will go around the buildings in terms of the side diffraction and shielding effect in the vertical plane. Here we have a building with different elevations. Again, this could be some sort of a hotel structure, a main hotel, and then conference rooms, maybe some other rooms for gym, fitness rooms, and so on. So here we have a building with a courtyard, and so we have a drive-in into the courtyard, or opening into the courtyard. And here we have the apartment complex defined. And then here we have a piece of a building that is floating. And again, it's overlapping with the sides of the apartment complex. So these are connected. And then again, here we have the noise being able to go underneath that building section into the courtyard area. And yeah, so this is kind of how you can put in openings. Next building here is this here. So this looks like a donut hole. So we can look through that. And again, here we have a building on the sides, a building at the bottom, building at the top. Right here at the top, that's floating. And then here again, two buildings here on the sides, and so that's kind of how this donut is created. And then here again a couple other examples of different roof structure. So here again we have hitch buildings, a gable right here. So here the gable is just a small piece of a ridge line that overlaps with the wall. Now here, to create this this way of how it basically wraps around this this gable, I added additional coordinates to the right and left, and then with that the program has like corners or coordinates that it can adjust the roof or the outline of the gable. So here we have hitched roofs here. So again, the ridge line up to this point, ridge line from here to here. And then here we have again a complex, a building complex with a courtyard and several gables in here, right here. So here we can again see these additional coordinates and these ridge lines that are from one facade going to the center of the roof. And then here we have a building that is also floating inside there, and this is also sticking out through the roof here. All right, a couple of domes here. So a circular building with a ridge line at the very top. Here you can kind of notice that we have different color coding for the different buildings for the roofs, and this is maybe let me go over that. So here we can go into the object types in the 3D view here under environment buildings. So here we have different building types that are defined here, and under the 3D graphics we can see, for example, here these circular domes here are defined as commercial. So here is the, actually no, that's not the right one. Let's see which one that is. Oh, there we go, the slanted roof. So for these hotels, so I guess it's defined as a hotel building. And then here we have slanted roof with this orange or yellow, dark yellow roof line. So again, with each of these buildings we can define different color coding, and under the 3D graphic menu right here. And then you can also define transparency and other parameters. Now here also we can see show floor lines. So here on this building we can see the floor lines. So this is I don't know, 4 or 5 story buildings. So you can see the separation between these floors showing the floor lines. All right. So here are half domes. That's kind of basically split in two with the ridge line in between. Then we have a couple of butterfly buildings or butterfly roofs right here. Again, the brown type of, so here these are defined as commercial, building types commercial, and that is probably defined as a brown roof. Let me redraw the 3D graphics. All right, here we go. So here are all kinds of different ways of how you can assign the roof lines by just defining different ridge lines inside the roof area. So with different elevations you can get this pattern or this shed pattern. And then here again we have also some other roof structures here that are gabled right here. So here we have a gable that is also hitched here, L-shaped. Now here one thing may be interesting here, these buildings that are I believe called mansard roofs. So the roof line changes and is hitched. All right, and then here we have lean-tos. I believe that's how this roof line is called, the lean-to. And then here we have two buildings that are leaning against each other with different elevations. And for those we have the ridge line basically almost right on top of the edge of the facade, and then with that it raises that roof line. All right, that I think that ends the input here, or the view in the Geo-Database in terms of the different structures. So here you can kind of see the variety of different buildings that we can create with this in the Geo-Database. All right. So let me close that, and let's go into the graphic program. And here, first of all, I want to kind of show in terms of the site plan view, just by defining different buildings and building types and referring that, we can color code in a site plan view the differences. And I use that a lot in terms of visualizing, okay, these are residential homes, these are commercial homes in a project. Then of course in terms of the 3D view, let me open that. So here we have a 3D view of the buildings that I just went over. And here I'd like to maybe just discuss the map object types again in more detail. So here we have all these different buildings right here. And then for each of those buildings we have base settings in terms of the color coding for the edge lines, the hatching, the colors. We have cartography definitions that also allow us to add different patterns on the buildings besides just the shading. So of course here we have shading, but then we can also do other patterns on that, or different text boxes in there and all that. And then we have the 3D graphics settings, and these allow us to make the building transparent. So in this case, one of the examples is here, this ring is transparent, so I can actually look in. All right. Here we have different color coding for the presentation in the 3D view. And then of course there's additional options like show floor lines. So that's what we have right here for this building, and for this building we are showing the floor lines. That could be of interest in terms of visualizing the different facade levels and what the floor levels are, or which floor that is happening. All right. Here just a post-edit addition to this video. I want to show how we can add object types, especially with the buildings. So on the parameters, object types in project. So here we see all the object types in this project, and under buildings we can add additional sub-buildings or additional object types. So to do that, you typically would select on any of the ones that are already existing in the default, and then up here we can click on this duplicate or copy layout, and with that we can create an additional building type. And then with that we have then the option in the Geo-Database to add this building type or select that building type for building. And then with that we have different color coding, presentation in the 3D view, and so forth. So if I want to, for example, duplicate this auxiliary building, now we can go in here and change that, and then just call it, for example, that could be the residential buildings. We can change the full color, so that could be, for example, a green. We can change the 3D view. We can change the color coding on the top or the sides. And I click OK. So now this parameter is now selected, or new object type is defined as a residential building. So that's different to this residential or this commercial, and so forth. Now in terms of the 3D graphic, how to create a 3D graphic, you go into the edit map, and in the edit map we have the view, and here we can switch from sitemap view to 3D model view. So again, sitemap view right here. We can reset the view. Rotation 500 to 0. We can zoom in. And then of course by just changing from view 3D map to 3D model, it switches over to a 3D model. In here we can use our mouse or the wheel on the mouse to zoom in, zoom out. With Control and the left mouse we can rotate up and down, change the tilt, and take a look at the geometry. Now in this model I also have some receivers. So here we have the receivers, and we can go to any of these points, let's say residential home, and we can look into the model from that residential home. Second floor, 12th floor, okay, and lowest floor. All right, so let me go back to the full view, and with this I'm closing. Stay safe and healthy. Thank you.